Okay, here we go. Make sure you have your graphing calculator ready with you. Your notebooks should be open and titled 1-7 Parent Functions and Transformations because you just did the warm-up. So let's take a look at some functions that we might have dealt with in the past that's going to become our parent functions. So in your notebook, I want us to sketch each of these 5 parent functions. We just need little sketches of the graph. So we've got linear, quadratic, cubic, absolute value, and square root. Now some of these I think you probably already know. So linear functions, we want coordinate axes, we want to label them with x's and y's. And we have the equation y equals x. And y equals x, you can go to your y equals menu and just type in y equals x, but hopefully everybody remembers that's just a linear function with a slope of 1 and a y-intercept of 0. All right, and I'm just going to keep going and keep sketching. My next one is y equals x squared. And hopefully remember that looks like a parabola that opens up, centered with a vertex at 0, 0. And then I've got my cubic function, which might not be familiar, but hopefully you maybe talked about it in Algebra 2. Again, check it on your graphing calculator. You can always remember, pause the video here so you slow me down. But the cubic function is going to look something like this. At least a simple parent cubic. Cubics can look a little bit more complex than that, and we'll talk about that later on. That little spot where it changes is not called the vertex. That is called that spot right there is called the inflection point. All right, 2 more graphs to go. Absolute value function. All right, so now on your graphing calculator, to graph this one, absolute value, you have to go into y equals, and then you have to go to the math menu, and then arrow over to the number menu, num, and then you'll see the first thing is abs, and that's absolute value, and then you put an x in the side of there. And the absolute value function returns, hopefully you remember, always positive values. So it's a linear function, y equals x, but that's always positive. So it's looking up, straight up like that. Should be straight lines with slopes of 1 and -1. And the last function then is the square root function. I'm running out of room here, but you got room in your notebook. And that one is the inverse of the y equals x graph with a restricted domain. And that one, if you graph on your graphing calculator, should look like that. So it's half of a sideways parabola. Those are our 5 parent functions. And what we want to do is we want to transform them. We want to change their position and change their shape. You know, we were just playing around with the position and shape of the line by changing the slope and the y-intercept. Let's review when we change these. All right, so next I have a little review here of things that happen with a function. That f of x notation means my function. So if I'm going to be multiplying by a value in front of the function, like 2x squared, that is going to vertically change the graph by stretching it or compressing it. In fact, kind of like making it wider or narrower. If the number is a negative number, then that's going to flip the graph upside down. So if a is less than 0, the graph is going to flip. All right, again, remember, you can pause at any time and then jot some of these things down into your notebook. If I multiply by k next to x, that is going to do some horizontal changes. And that, I will say, is not going to be as often as what we're going to wind up seeing, at least for now. Eventually, we will see that when we look at a different function down the road. So multiplying changes the shape of the graph, stretching it vertically or stretching it horizontally. And that's, I have written down at the bottom of the screen here. You might want to make sure before you move to the next slide, copy these 2 statements down. Adding and subtracting, D and C at the end, well, those things should be pretty familiar. If you add or subtract, you're going to move the position of the graph. It shifts it up and down. Shifting up and down happens with the C value, just adding a value to the end. And adding or subtracting to the x value means you're going to move along the x-axis, and that's going to move left and right. And that gets a little tricky because of the subtraction there, and we'll talk about that in a second. So again, jotting some of this review down onto your notebook. Pause, and then before I go on to the next screen. So now what we're going to do is we're going to play around with what we think some of these graphs look like. So if I have the absolute value of x, now again, my parent function for the absolute value function looks like a v. It's basically the y equals x graph that's been reflected up. But now what do you think would happen if I have the absolute value of x plus 2? Well, adding changes the position of the graph, so is that going to be moving it up and down or left and right? Well, since it's added to the function, it's going to affect the y value of the function, meaning that it's going to move the graph up or down. Positive means I'm going to move up, so a pretty good guess here is that it's going to move the graph up 2 units. So what I would like you to do is to kind of sample sketch what you think it's going to look like, and then maybe pause the video here, grab your graphing calculator, and type that in. Again, absolute value can be found from going into the math menu, then the number submenu, and then you'll see abs inside of there. And sure enough, this is exactly what this looks like. So I'll do a couple more with you here, but again, pause your video maybe when we get to the next slide, and then try to sketch it first before you grab your calculator. Oops, that's the same function, so move on. All right, so absolute value of x minus 1. Subtracting 1 from the function, well, that means I'm just going to make all the y values go down 1, so my guess is it looks like this, and I'll label -1. And if I check with my graphing calculator, I think I've got a good guess, or a good check. All right, now this one. I would pause right now and sketch what you think it's going to look like. Grab your graphing calculator and check. Now, the weird thing about this one is you think it's adding 1 to x, so it's going to move everything to the right one, but it actually doesn't. This is a transformation. Remember now, the transformation notation on the other slide was really x minus something. Remember, it was x minus, I think it was d or c, I forget now. But I think it was c. This is technically x minus -1. X plus 1 is really x minus -1 hidden in disguise. So the shift is really a -1 shift. So when moving things along the x-axis, it kind of looks the opposite of what it should be. Plus 1 moves it to the left, -1 moves it to the right. So if you change it to always be subtraction to be the equivalent form, well then you'll be able to easily see what the translation is. It is an actual translation of -1. So at this one, pause, sketch what you think it's going to be, check your calculator. This is a shift to the right, because I'm subtracting +2. Now again, you see x minus 2, you'd think you're going to the left 2. Remember, that's the operation of subtraction. I'm subtracting a +2. It's always that subtraction form. Two things going on here. Pause me, try it, see what you get, and check it with your calculator. Is this what we thought? I know my graph is a little messy here. You're probably doing it nice in your notebook. I have a shift 3 to the left and a shift 1 down. So therefore my vertex, instead of being at 0, 0, now is over here at -3, -1, and I make my V. Pause it, try it, see what you get. All right, so definitely have a shift up 1 because of the +1 outside, but I've got a negative out in front. What happens when I multiply by a negative out in front? That's that a value way out in front if you check your notes up above. That is a reflection. It is flipping, oops, wrong graph. It is flipping the graph upside down. So this is an upside down absolute value function shifted up one. All right, so that was a couple to try. So now you're going to go into the practice worksheet, open that up. If you're at home, you can download and print it if you have a printer. If not, no big deal. Just do it in your notebook. You can see that you're going to be sketching some graphs. So try sketching them by hand first and then doing them on your graphing calculator. Check them on your graphing calculator. Then I'm going to have you write equations as well. So think about those vertical and horizontal shifts, and then writing some equations from some descriptions as well. You'll also find an answer key on the website as well. All right, good luck, guys.